Hello, let's get started with lesson 25 by logging into Clever. All right, so here is your icebreaker warm up for today. If you were an animal, what animal would you be and why? So this is lesson 25 of week 13. We are diving into the groups of the periodic table. Thanks for joining me. A couple of announcements. So first of all, the end of the 6 weeks is the Thursday, the 19th of November. So grades will officially be posted in about a week and a half. That means that I will be doing my best to update grades, and you need to be doing your best to make up any missing assignments. So please make sure that you're on top of that you're putting in the effort to get your grade where you want it to be. A reminder about Edpuzzle, there are required Edpuzzles each week. The recorded versions of the lessons are only for if you miss the live lesson. You do have to do either the live lesson or the recorded lesson though. One, because it's necessary, and two, you won't know what you're doing on the assignments unless you do this. So let's remember our expectations. We're always going to be safe, responsible, respectful, prepared, and here. And as always, thanks guys for showing up for yourselves, for improving and for growing. So like I said, this week we're talking about how elements are organized on the periodic table. We've been thinking about patterns and groupings and how that works. Now we're actually putting all of those skills to task by looking at the actual periodic table. So there are 2 new assignments that will be posting or are posted that have to do with this lesson. So before you try to do 58 or 59, you better be watching this lesson. So we will need a periodic table, and I will ask you to look at it again later, but you can pull this up now. And here is what I'd like you guys to do. Here are the first 9 elements of the periodic table, the first 9 elements. What I want you to do is I would like you to take a look at any of the characteristics or character traits listed about these elements and come up with a way to put them into 3 distinct groups, okay? So I'm gonna ask you what's in group 1, what's in group 2, what's in group 3. Just tell me which elements you're putting in each group. There is no right or wrong answer here. I just want to see how you would actually try and group these. So next, I need you to explain how you chose these groupings. What did you do, or what was the pattern or the structure that you used to group them? Good work, y'all. So we have been recognizing and predicting patterns, and we are now going to turn that idea towards specifically how the periodic table is organized and the patterns that we can see there. So remember that the periodic table is organized based on characteristics. Physical and chemical is what it was originally based on, and now we understand that there's atomic characteristics and patterns that can also be seen. So we talked about some physical properties: states of matter, shape, elastic, brittle, hard, soft, magnetic, color, smell, toxic, not toxic, and then metal and non-metal was a big one. So we learned last time that metals are conductors, they're malleable, and they're ductile. That means conductors can allow heat or electricity to flow through. Malleable means it can be shaped. Ductile means it can be spun out into a wire. A non-metal is just not those things, okay? There is an in-between. We have a lot of metals, a lot of non-metals. There's this small sliver on the periodic table of things called metalloids. So these metalloids are not fully metals and not fully non-metals, and they kind of are the dividing line. We then we learned and reviewed the chemical properties. So the periodic table can also be based on these and those groups. So are they highly reactive with, say, water or a specific other element? Or is it reactive in that it doesn't react, which we will call inert? So Dmitri Mendeleev took those physical and chemical properties and used them to create groups on the periodic table that looks very, very similar to what you see today. So one of the important things that we need to be able to identify is where the metals, the non-metals, and the metalloids are. And so looking at this periodic table and how this is described, our metals are this orange column, this kind of yellow column, this little rose column, these guys over here, and then the lanthanoids and actinoids, those fit in, those are also metals. Our non-metals are over here in this right corner, and then our metalloids are separating the two. So here's kind of the better image, but that is something that you absolutely need to be able to visually identify. So the periodic table is then grouped into literally things called groups, and those are the columns of the periodic table. These columns, every element in that column have some things in common. One is they're going to have a lot of the same properties, and the reason that they have a lot of the same properties is because they have the same number of these things called valence electrons. So valence electrons are just the electrons in the outside shell. So in helium, it only has 2 electrons. It only has 1 shell. Those are its valence electrons. In this chlorine, it has 17 electrons total, 2 and then 8. And then the 7 in the outside shell are the valence electrons. Over here in this potassium, 19 total. That 1 lone electron in the outside shell, that is its valence electron. So with valence electrons, every element in the first column has 1 valence electron. Every element in the second column has 2 valence electrons. We skip these middle ones, the transition metals, because they are weird. This is the third column. Columns are up and down. Everything in that column has 3 valence electrons. Fourth has 4, fifth has 5, sixth has 6, seventh has 7, eighth has 8. Do we get the pattern? So if you're in a particular column, that's how many valence electrons you have. Now, so let's look at this right here. How many valence electrons does this atom Rb have? So the correct answer is 1 because it is in the first column. All right. So another way it is organized is through periods, a periodic period. Isn't that a silly name? So the periods are just talking about the rows. So groups are columns vertical, horizontal rows are periods. Every element in that row, although they're all in different groups and they have different amounts of valence electrons, what they do have the same is that they have the same number of electron shells. So remember our electron shells, also known as levels or orbits. As you build your Bohr model, each element has an additional shell that is added. So the first row has 1 shell. The second row, every element in that second row has 2 shells. The third, 3, fourth, fifth, sixth. Do we get the pattern? First has 1, all right? Has 1 shell. As you go down, you add more shells. So how many shells does this rubidium have? So it has 5 shells because it's in the 1, 2, 3, 4, 5th row. All right, so the assignment that you guys are going to be doing today is you are going to be identifying some common characteristics of the major families or groups of the periodic table. You're going to be doing so by working on this assignment here. Each of you is going to be assigned your own document. You're going to start by telling me the periodic group. All elements in a group have the same number of valence electrons and properties. The periodic period, all elements in the row have the same number of shells. But you're going to be using these 2 websites. One, or this website, which is about the different families. So that's one option that you have to gather your information. You'll see each of the families that you have to record information about listed over here on the right. Or the other option is you can have access to a slide deck that I created that gives you the same information pretty much. So whichever one works for you. So for alkali metals, you have to write down which elements are alkali metals and then what are their common properties. So going back to this assignment, what I've done is using the periodic table, I saw that lithium, sodium, potassium, rubidium, cesium, and francium. I keep changing tabs on y'all, but I hope you're still following along. If we're looking at the alkali metals, that's this first column. We can see that lithium, so Li, Na, K, Rb, Ss, Cs, and Fr, francium, are all in the first column and all these things called alkali metals. So that is why in that first box for what elements are examples of alkali metals, I listed all of those. For the common properties, back on on either the website or on the slides, you can read and it'll tell you that alkali metals, because they're the first column, they have 1 valence electron. They are metals, they are highly reactive, and they are shiny, lightweight, and malleable. So your job is to do the 7 other major groups, okay? So you're using the information from the website or from my slide presentation. Okay, so to finish things off, tell me, if I am an atom that has 5 valence electrons and 4 electron shells, what atom am I? All right, so I know this is tricky, and we're going to have plenty of review questions like this over the next couple weeks. But if it has 5 valence electrons, that tells me it's in the fifth column. So 1, 2, 3, 4, 5. It is somewhere in this 5th column. If it's in the 4th shell, I have to go down 1, 2, 3, 4. So if I check my 4th column and or 4th row and my 5th column, the correct answer is arsenic. All right, how did we feel about this lesson? Thank you guys for being honest and sharing. So you have these 2 assignments that are due or assigned now, due at the end of the week. Keep working to get caught up on your assignments, and I will see you guys next time. Thank you. Have a great rest of your day.